Welcome. In this series of videos, we will look at topics common to both the PowerBasic Console and Windows compilers. Today we will look at the definition and use of user-defined types. In this series of videos, we'll be covering topics which are common to both the PowerBasic Windows compiler and the PowerBasic Console compiler. In order to do this, I've set up a small common library to allow us to display information on the screen from a program regardless of whether you're using the Windows or the Console compiler. There are three basic functions in this common display library. There's prep output, log, and wait. The prepare output function takes a console name as a parameter, an X and a Y start coordinates, and optional rows and columns. Since this code is designed to work regardless of whether you have the console or the Windows compiler, we're using a conditional if statement, which is handled at compile time, to test if we're actually inside the console compiler or not. So you'll see in here there's an if-def pbcc32, which if that's set up, we are in the console compiler, and it will prepare the functions accordingly. If we're in the Windows compiler, the same three functions will be prepared, but internally they'll be slightly different. So for the console compiler, we're using a standard console window, and for the Windows compiler, we're using a text window. User-defined types, as the name suggests, is a variable you can design to your own specifications. Whereas the standard variables hold one single piece of information, a user-defined type can hold many pieces of information within the same construct. Let's have a look to see how we set this up. If we create a type end-type statement with the name of the user-defined type we wish to create, in this case UDT car, we can set a number of pieces of information up within this user-defined type. Here we're storing three independent strings inside the type. Strings within a user-defined type must be of a fixed size. So if we want to make use of this user-defined type within our own functions and subroutines, we merely need to declare them as so. So if you want to set the values within our new variable, which is the uCars variable, we use the uCars, then a dot, and then the element you wish to amend. As so. So you're setting each of the elements of the uCars user-defined type with a string. To make it easier and less verbose in the typing, we can use the prefix command as so. This saves you a little bit of typing and makes your code a little easier to read. Now, having stored this information inside this user-defined type variable, we may want to output it to see if it's arrived successfully. All we need to do is to put in our information with the element name of each of the elements we wish to print. Now, since these are user-defined type variables and the log function is expecting a string, in order to get this to work without erroring, we will add on an empty line string to the end of each of these to allow PowerBasic to convert them into dynamic strings. Now, each of these user-defined types are of a fixed length. If you wish to trim off any spaces off the end of the string, we can use the trim command, and if we run this now, the information will print out quite happily. Now, if you wish to store more than just string information in here, if you wish to store a number, you can quite happily set up a number. We can use a enumerated type for this one. Using the singular option in here allows you to populate the first number, and the 4-door would be the value 2, the 5-door would be the value 3. Singular will allow you to actually use these as constants in their own right without you having to define them. And we would populate these down here using the element of the user-defined type and %sign for the constant and putting in the value in here. And we can print this one out by putting in the element of our user-defined type. Now, as this is a number, we would want to use the format command to turn it into a string, and we wouldn't need the string at the end. And if we run this now, it would come out as a 1. Now, this is using a user-defined type on its own. You can go a little further than this, and if you wish to store information on many cars, you could dimension an array as our user-defined type. And we can say we want to store information on 10 cars. And your method of doing this would be much the same as we did before. And having set our array up like that, we of course can use the prefix command if we want to make it less wordy. Like so. And if we push this out to the log, and run this now, and if I equate, didn't I do 3-door? No, I didn't do 3-door. 4-door. Yes, and if we name our array correctly, and there's your information, quite happily. Having created an array of the user-defined type car type, you can then populate it with up to 10 different values. Of course, you can set that as 100 or 1,000 or 10,000. So it gives you a very powerful way of actually maintaining a small database within an array. This is a small introduction to user-defined types. Thank you for watching.